Howdy folks, and welcome to part 2 of my comprehensive guide to pfSense. In this video, I'm going to be talking exclusively about hardware in terms of the actual hardware in the machine itself, as well as how to actually physically connect your network up. Now, in the part 1, it was an intro and I talked about some of the things that pfSense can do, but without equally good hardware to put it on, it's still nothing. So this video will hopefully solidify all of the everything you need to know about just hardware and configuration wise. So in this video, I'm going to be going over minimum hardware requirements. I'm going to be giving some common configurations for pfSense in homes. I'll hopefully give some insight into choosing how to design your network, and I'll also make note of some less known mistakes people make and some caveats that you may not be aware of. Now, before I go any further, I just want to mention what I'm not going to talk about. So I'm not going to be giving exact parts to go out and buy to build a pfSense router. It's going to be up to you to purchase or use existing parts you have based on your needs. I'm also not going to be talking about embedded pfSense or ARM-based systems. So this is going to be only x86 hardware. I also guarantee that somebody out there is going to have something to say about one or more of the configurations that I'm going to show. With something as configurable as pfSense, there's always going to be something else that you can do. Really, the possibilities are endless. So this is just going to be a basic intro to the concepts. So, leave it in the comments if there's anything you may have questions about, and I'll try and help you as best I can. So just a bit of an outline as to what I plan to go over today. We're going to talk about the CPU, memory, network cards, VLANs, wireless, and even running pfSense in a virtual machine. So without further ado, let's jump right in. So when building a computer or a server, I usually start out with the CPU and pick parts based around that. So that seems like a good place to start with this. Now, unlike most builds you may have done, with pfSense, more processing power does not generally improve performance. And when I say that, I mean that most CPUs from the last decade are more than enough to route gigabit traffic. So unless you're routing 10 gigabit Ethernet or InfiniBand or something like that, you have absolutely no reason to go with anything other than the cheapest CPU. So this includes things like Celerons, Pentiums, Atoms, Semprons, whatever the hell you've got. Spending more will not generally have any effect whatsoever unless you're running a crazy configuration, in which case, you probably already know what you need. I mean, I personally use like a 1.86 gigahertz. It's an E6300, Core 2 Duo E6300. I used that for 10 years for my network of over 40 devices. And the only reason I replaced it was because the motherboard gave out. So it was still perfectly capable of handling all the traffic without any delays. So like CPU, pretty much anything will do. However, there are some things you may want to consider. Now, if you've read online about pfSense and what CPU you want to buy, you'll undoubtedly have come across somebody who says that PF, which is the core application behind pfSense, thus the name, is single-threaded. So thus you should buy a CPU with really fast cores, like very few very fast cores instead of many slower cores. And this was true up until pfSense 2.2. So now PF is fully multi-threaded, so there's absolutely no reason to stress over the number or the speed of cores. So the geometry doesn't matter anymore. Now, most of what runs on your pfSense box will utilize multiple cores. So this includes the interrupt service routines for most network cards, and I'll talk about that when we get into network cards. It depends on the driver, of course, but generally speaking, no matter what you run, it should be distributed across all cores. So don't worry about the CPU geometry too much. And this news sort of might encourage you to go out and fetch an old Pentium 4 machine you've got in your basement and use it as a router. And while that will probably work, assuming that it meets all the other requirements, you probably don't want that thing running simply due to the energy it consumes. I mean, if you don't pay for electricity, then it's probably fine. But otherwise, you probably want to calculate the total cost of ownership for something like that versus an alternative. And my argument for this is as follows. I mean, look at the state of wired networking now. Gigabit Ethernet has been the standard for consumer gear for a pretty long time now, and it's not looking like it's going to be replaced in the near future. I mean, 10 gigabit Ethernet is in large businesses, but it's not marketed for consumers yet, nor do I see it being something consumers would want until either internet connection speeds do some, massive increase, or I mean, most consumers don't have file servers in their houses. So if the hardware is powerful enough now to pass gigabit traffic, that means that as long as the underlying network standard remains gigabit Ethernet and it doesn't change, I mean, your router will always be powerful enough. So just keep it in mind that routers have a much longer lifespan than most desktop computers or even servers. So, I mean, like I said, mine was in service for a decade. So it depends on, that's more what you want to look at when you do the calculation. So it may be worth it to invest in new hardware than to go with old hardware. But again, it depends on your needs. So moving on to memory, pfSense uses the store and forward switching architecture. Now, this means that incoming packets are copied into RAM, processed, and then they're copied out of RAM and forwarded out the corresponding interface. So there's 2 memory transfers per packet required. And this is the same architecture that's used by pretty much all consumer gear and even low to mid-range enterprise gear. And the memory bandwidth of DDR2 is far higher than necessary for gigabit networking. So there will be no bottleneck with pretty much any memory you use. So it doesn't matter what kind of memory or what speed of memory. The only real question is how much memory do you need? Now, some people will argue this figure, but a reasonable installation with a couple of packages will use about just under 512 megabytes on its own. So as a result, I would personally recommend at least a gigabyte of memory for most basic installs. Now, you could technically do with 768 megabytes, but that's not a common amount of RAM unless you've got some old 256 megabyte sticks somewhere. You're not going to be able to get that configuration. So I would generally only install more than a gigabyte if either you already have it and it's free, or if you'll be installing packages like Squid or NTOP or a couple others which use a lot of memory by themselves. Now, I personally have 6 gigabytes in my router, and both because I had a bunch of DDR2 lying around from old computers, so I might as well put them in something, and also because I use Squid, so I wanted to give it as big a RAM cache as possible. So memory, generally speaking, you can get away with a very, very small amount of memory if that's what you've got, but if you have stuff lying around, throwing more at it is not a bad thing. So, I mean, really, that's all I think I need to say about memory. It's very simple. So I want to move on to network cards now. Now, I'm going to argue that network cards are pretty much the most important components in the router. And that's because all traffic that passes through the router is either generated or received by the network cards. So they're going to govern the performance, stability, configurability of the entire router. And not all NICs are created equal. And they can have more of an impact than you might think. So it's a good idea to budget for the right cards, if at all possible. Now, like I said at the beginning, I'm not saying you need to buy exactly, model XYZ of network card, but the generally accepted rule with pfSense is to only use Intel network cards. Now, in case you're wondering, I'm not affiliated with or sponsored by Intel to tell you this. The answer to why you should use Intel has to do with both the hardware and the software support. And because a picture's worth 1,000 words, I'm just going to go into a little bit of an aside here. Now, I recently picked up a bunch of 6-inch silicon wafers, which I'll do a microscopic video on soon, but I can use these to illustrate my point. So what you're looking at is 2 silicon wafers, they're 6 inches, and these are what they use to make semiconductor dies. So they use photolithography to manufacture the wafer, and then they cut out each of these dies. They encapsulate them in a plastic package, and that can be mounted on a circuit board. That's what we see as chips. So the cost of making one of these wafers is essentially fixed no matter what kind of chip you're manufacturing, assuming that the process by which it's manufactured is the same. So as you can see, the dies on the left are much bigger than that on the right. So since the cost of a die is the wafer cost divided by the number of usable chips on the wafer, the smaller the die, the cheaper you can sell them for, and or the higher the profit margin you can make on the chip. Now, before anyone tries to correct me, neither of these are network controllers. In fact, the one on the left is a MIPS processor, and the one on the right I haven't identified yet, but it's probably an op-amp or a logic gate or something. But my point still holds. Now, you may be wondering, how the hell does this tie into buying network cards? But companies like Realtek, Marvell, they try to reduce the die size as much as possible. And they do this by removing pretty much all the circuitry, which can be supplemented by software. So they only include the absolute minimum hardware. And this results in an extremely large and complex driver, which relies on the CPU to do most of the work, for which it's really not optimized. Now, not only this, but the driver quality for BSD is usually lacking, and it can lead to problems beyond performance. Now, Intel, they're a hardware manufacturer, and their network controllers do most of the heavy lifting in silicon. And the drivers are thus very simple, they're very fast, and they have very good support for Unix, including BSD. So, just as an example, take transmit and receive buffers, for example. Most Realtek cards have no more than about 300 kilobytes of buffer memory, which is just enough for a regularly sized TCP window. Intel cards, on the other hand, even the consumer level cards, have pretty much a standard minimum of 8 megabytes of buffers, which is very useful when things get busy on your router, because you don't want to have a buffer overrun, because then a bunch of packets gets dropped and all sorts of weird stuff happens. So now that you hopefully agree that you should get Intel network cards if at all possible, how many network cards do you need? Now, the general setup with the router acting as a gateway requires 2 network cards. One for the WAN, which is connected to your modem, and one for the LAN, which could be connected to a switch, which then connects to all the rest of your devices. Now, every additional subnet requires its own network card. And if you're fortunate enough to have more than one WAN, then you'll need another NIC, of course, for that as well. So I just want to point out that when I say NIC or network card, this refers to how many total ports you have. So you could easily get a dual or a quad port card and call it a day. So it's just one card, but with 4 ports on it. I'll just call that 4 NICs for this video because it's easier. Now, I also want to mention that you don't need to purchase brand new network cards. In fact, I never purchase brand new network cards, almost ever. It's very economical to purchase second-hand network cards off of eBay that have been pulled from old servers. You end up getting enterprise-quality dual or quad-port NICs for pretty much the same cost or even less than that of a brand new single-port consumer-grade NIC. So there's absolutely no reason you should buy a brand new card there's really no reason. I can't think of one, to be honest. In all reality, gigabit Ethernet is gigabit Ethernet. So it doesn't matter if the card was made 6 years ago or made yesterday. It's pretty much going to perform exactly the same and do the same function. It doesn't change anything unless you're you're in a data center and you're doing bleeding edge stuff. It doesn't matter how new or how old the card is, as long as it's got the right connector. Of course, generally speaking, you want a PCI Express network card. Only if you're trying to repurpose old hardware would I try to do a PCI network card. I really wouldn't do that unless you absolutely have to. Because PCI has bandwidth limitations. So if you're trying to run multiple gigabit cards on PCI, you may encounter a problem. But again, you have to deal with the hardware that you have. just keep it in mind that you can get things used. So I'll start by diagramming the simplest setup here. Now, when I say simplest setup as a gateway, I pretty much mean the following. We've got a modem on the left and a switch on the right, and I'm just going to represent that. That's going to sort of represent the LAN in this situation because obviously you'd connect all of your devices to it. And we can connect a router, which is, of course, that's the symbol for a router in the center there. We can just connect it with two network cards, one to the WAN, one to the LAN. Of course, I'm depicting them as separate cards. You can use a dual port card and just have a single card for this. Doesn't matter. Now, you may have been thinking in the back of your mind about using an old laptop as a router. Maybe the hinges are broken, maybe some keys are missing, but can you turn it into a router? And they actually make a lot of sense for a couple of reasons. I mean, they're small and compact. You can put them pretty much anywhere. They're generally designed to be energy efficient because, of course, they have to run on a battery. And they also have effectively a built-in UPS, right? When the power goes out, they just switch to battery power. So generally speaking, you can save a lot of money by repurposing an old laptop. However, there are some problems, and they have one sort of critical flaw, and that is that they only have one wired network card, and there is no way to add another. You can't just add in, there's no PCI Express expansion slots in a laptop, that you can add a NIC to. Now, in case you're thinking about those USB 3.0 gigabit adapters, no, don't buy those. They suck. They're not going to work properly with pfSense, so just don't even bother, to be honest. Not only that, but most laptops also don't have Intel network cards in them. I'm not saying every laptop doesn't. The business class laptops, also some high-end gaming machines do, but you've really got to check. So if you're on Windows, you can go to Device Manager and find out. If you're on Linux, you can run LSPCI and find out who the manufacturer is if you're unsure. Most manufacturers, decent manufacturers, will actually tell you the manufacturer in the spec sheet of the laptop. So you can find out what you actually have. And it may seem, just from these two things alone, that even despite of it, the advantages of using an old laptop, you just can't use one because it only has one NIC and it may or may not be Intel. But there actually is a way, and that is to use virtual LANs or VLANs. Now, VLANs allow you to use a single physical network card port to serve multiple physical subnets. So this means that you could connect both your WAN and your LAN to the router via a single port and not end up connecting them together. And this physical connection is done using an external device, which is a managed switch, which I'll talk about in just a moment. So if I adapt the previous diagram using VLANs, we get this. You can see we have both the modem and the network card from the router connected to the same switch. And if I just sort of clean that up a little bit, this is the exact same thing, just it looks a little bit nicer. So to understand how this is possible without the WAN being connected directly to the LAN, we need to look at how VLANs work. So this is just going to be a super quick intro into VLANs. So Ethernet frames are tagged with an integer value which corresponds to the virtual LAN that the packets are either coming from or going to. So in that setup, we would create two virtual LANs, one for the WAN and one for the LAN with a different tag number. And pfSense can then be configured with two virtual interfaces that correspond with each of those tags. Now, the reason you need a managed switch over a regular, more common, and of course less expensive unmanaged switch is because you need to configure which ports on the switch correspond with which VLAN. So on an unmanaged switch, all ports are forwarded to all other ports, so of course that won't work. Now, that being said, you can of course connect any device to each port on the managed switch, and that means that you can connect unmanaged switches to the ports on your managed switch. So if you want to get away with buying a cheaper managed switch with fewer ports, like a 5 or an 8 port switch, you can connect other unmanaged switches to that to expand out, and you'll just get a tiny latency increase from the extra switch delay. But you can do that if you want to try and save money that way. And again, if I just diagram that up here, you can see that the ports would be configured sort of like this. I've color-coded them red and blue here. You'd have all of your LAN ports would be on one VLAN, your WAN would be on the other, and then the port to the router would be on a member of both VLANs so that it could pass traffic back and forth. So the question that you may ask yourself is, why would you want to use VLANs in the first place? And the answer that I would give is when there are more subnets than you can physically add network cards, or basically the point where it becomes unfeasible. In the case of a laptop where there's only one network card, VLANs of course make sense. If you have 10 subnets, for example, it's not practical to have 10 network cards in a machine. So again, VLANs make sense there. And my reasoning behind this is pretty simple. Managed switches are expensive, more so than dual or quad port network cards. So if you have a physical machine, a desktop, a server that you can actually put network cards in, it's generally better and cheaper to do that than to use the existing, single or dual port card and use VLANs. But of course, situation like a laptop, you can't add network cards. It's probably cheaper to buy a managed switch than it is to replace the whole laptop with another machine. So again, you got to look at what you've got. The other big thing is that VLANs can create bottlenecks, because in the scenario that I just showed, all the traffic that passes from the WAN to the LAN has to go through that single network card in, be processed by the router, and then be passed out through the exact same network card, through the exact same cable. So if you have many gigabit streams all passing through your router at once, well, of course, that's not possible. There's going to be a bottleneck in that one connection. So you may want to consider that. Again, most people in the home won't have this problem, but again, it depends on your setup for whether that would be an issue or not. You just have to be aware of it. Now, up until now, I haven't said anything at all about wireless networking. And as much as I hate wireless sometimes, it's a necessary part of pretty much all networks nowadays. So if you want to set up wireless with pfSense, you have one of two options. You either use wireless cards in the router itself, or you connect external access points to a wired network card in the router. So by internal wireless card, I pretty much mean you take a regular wireless access card, either USB or PCI Express. Generally PCI Express would be preferred, but most of them are USB dongles now. And you would use that to, instead of connect to an existing network, you'd actually use that to broadcast the BSS, to broadcast the network instead of connecting to it. So that's what I mean by internal, where the card is physically in the machine or connected directly to the machine. Now with an external access point, you take an external third-party device and you connect it over wired Ethernet to the router, which of course therefore broadcasts the network as normal. And you can use a regular wireless router for this and just disable the router functionality. So in terms of which setup is better, of course it's ultimately down to your needs as always, but I strongly recommend that you use external access points for pretty much every configuration. And the reason why is, there's actually a couple of reasons why. First of all, with external access points, you can place the access points anywhere you want. And as long as you can run a cable to it, you can put it anywhere. And not only that, but you can, of course, connect an arbitrary number of access points, which is really good for covering a large area. So you can put one upstairs, one on the main floor, one in your basement, one in that random room that has a dead spot. As long as you can run cables to them, you can do that. And like I mentioned, I tend to buy consumer wireless routers, the thing that we're trying to replace with pfSense. I buy those, disable the router part, and I just use it as an access point. And a lot of them are actually relatively good as access points. I have a TP-Link Archer C2, and it's been up for almost 400 days. And I've never had a single problem with it. I just use it as an access point. It's pretty much a wired Ethernet to 802.11 adapter, basically, and it works great as that. And they have switches in them, so you can daisy chain those devices together, or you can wire them in a star topology, or however it works for you. And you just sort of get that functionality for free. But sort of the real reason why you should use external access points over internal wireless cards is for support of modern Wi-Fi standards. FreeBSD unfortunately does not have good wireless drivers for Wireless N, and pretty much no drivers for wireless AC network cards. So if you want those kinds of speeds, you have to use external hardware, unfortunately, it's unfortunately disappointing, but that's the state of Unix and even Linux to this day. You just, unless you have the proprietary driver for that card, which you're unlikely to get, you just unfortunately can't use it. Now, internal wireless cards, they provide the ability to use pfSense to control the network and access control very precisely. So it's useful in situations where you need control that external access points don't provide. It might also be beneficial if you're using, let's say, a laptop and it already has a built-in Intel wireless card and you don't want to buy any new hardware and that'll work for you. That is also an option, and I've seen that done quite a bit. But just be aware that you're not going to get the same performance probably as what you would get if you used an external access point. So speaking of buying new hardware, some of you may be thinking, what about using existing hardware in the form of a virtual machine? And of course, pfSense, you can run it in a virtual machine on pretty much any VM software platform. It's actually quite common to do this, and it's used mostly in situations where hardware is scarce. Using a VM allows you to allocate only the resources that pfSense needs, so the minimum amount of processing power, the minimum amount of memory that we talked about, so you don't waste anything. And if you're thinking about doing this, just remember that you still need all of the requisite network cards in the host machine to connect the router to the physical real world. So, depending on your platform, whether you're using VirtualBox, VMware, whatever, you may incur some performance degradation as a result of the hardware abstraction between the virtual machine and the physical host. So also you want to keep that in mind. Now, you also need to consider that the host machine will need to be able to boot without a working network and run for a few minutes until the VM can start. So you also need to be aware that if the host goes down for any reason, be it planned or unplanned downtime, the entire network will also go down. Now, of course, that is unless you have a failover set up in place on another machine that can take over. But just be aware of this because, I personally don't like virtual machines because, I like to have a physical machine that there's no dependencies in place. It's just a standalone. I can fix it if anything goes wrong. But virtual machines are definitely a good place to start if you just want to experiment with pfSense and you have a machine that has the physical network hardware in place. Of course, you can always build a physical machine later if you like how it works. So when I do my installation video, you might want to just basically follow along with what I'm doing in a virtual machine and try that out. Even if it's not controlling a real physical network and it's just controlling some virtual on-machine, like on-host network, it's still a great way to experiment with the software. So just as sort of a quick overview, in this video, I've shown that pfSense will work with pretty much any CPU made in the last decade. You really don't have to worry about it unless you're doing really high-speed networking or really insane stuff. It should have at least a gigabyte of RAM to be happy, but of course throwing more at it is not going to hurt, especially if you're using Squid and stuff that really chews up the memory. You're going to need at least 2 physical network cards, unless you use VLANs. And of course, physical network cards are better than VLANs, unless it becomes, uneconomical to do so. And of course, all the network cards you buy, they should be made by Intel, if at all possible. You can use ones by other companies, but just be aware that their performance and possibly stability are going to be affected by that. pfSense will work in a VM, and if that configuration suits your requirements, go ahead. And wireless should be implemented usually with external third-party APs, but of course you can run it on Intel or integrated cards if you're okay with potentially lower speeds and older wireless standards. So I think that sort of wraps it up for this video. Hopefully I didn't forget anything. I think that covers all that you really need to know as to what to look for, either in a machine that you're going to salvage or repurpose or hardware that you're going to buy. In part 3, I'm going to go into installing pfSense on either a physical machine, or I might do it in a VM so it's easier to screencast. It's going to be a short video. Installing pfSense is extremely easy. There's a couple options you may want to change, but generally it's very easy to do. So that'll be definitely a quick video, and it'll be coming in a few weeks after the holidays. So until then, hopefully this was helpful and interesting, and thanks for watching.